Thousands of miles of coastline, and all of it an open skyway for enemy planes. With long-range bombers and seaborne aircraft, they can strike at our war industries, transportation centers, and other strategic points. They may come at any time from any direction. To be forewarned of this challenge to our defenses, several radio detector devices have been developed, one of which is the SCR-270. This device is used to locate and track enemy aircraft before they come near their objective. The SCR-270 is effective under all climatic and atmospheric conditions and can be used at night as well as during daylight. In this training film, we are mainly concerned with two parts of the equipment, the oscilloscope and the antenna. Shortwave beams, known as the output signal, are sent into space from the antenna. The output signal appears on the oscilloscope screen as a stationary signal. When the short waves meet a target, for example, a plane, a small fraction of them are reflected back to the same antenna. The reflected waves appear on the oscilloscope screen like this. This is called the target echo or image. As the antenna swings around, this echo reaches a maximum height. At that maximum, a reading is taken from the scale at the base of the antenna. This is the azimuth scale, and it indicates the direction from which the target echo is coming. By transposing this scale to a map, the direction of the target can immediately be plotted. For example, 90 on the scale is 90 on the map. The distance to a target can be read from a dial in miles. A ruler scaled in miles is used to spot the point on the map, in this case 60 miles. Thus, the exact location of the target is plotted. The operating crew consists of 4 men. To the left is the oscilloscope operator who works the oscilloscope controls. Beside him is the range reader who calls out the distance to the target. The third man is the azimuth reader who reads the scale at the base of the antenna. And beside him is the plotter who marks the targets on the map. Each of these men is trained to do every one of the 4 jobs. The oscilloscope screen can be called the camera eye of the SCR-270. Beneath it are 4 knobs that control the reception of signals. The one on the far left turns on the oscilloscope, and as soon as it is ready for reception, the operator turns the knob on the far right. This is the intensity control, and adjusts for the brightness of the signals being received. Just to the left of the intensity knob is the focus control, which sharpens the signal image on the screen. of these controls are manipulated at the same time, since brightness and sharpness can be judged simultaneously. A viewing tube is used to mask out any outside light which may interfere with the operator's observation of the signals. The tube is used at all times except during practice periods. The third control from the right is the vertical adjuster and is used to center the picture on the screen. The fourth control, on the far left, in addition to being the on-off switch, is the sensitivity or signal height control. It is set to give a maximum echo signal 1 to 1 1/2 inches high. Below these four knobs is the range dial. Turning this control will move the image from side to side. The distance on the screen between the output signal and the echo corresponds to the distance between the station and a target. When the left edge of the echo signal is lined up with the hairline, the distance to the target can be read in miles. A vernier is used for finer adjustments. When the left side of the output signal is lined up with the center hairline, the distance in miles should read 0, since the output signal originates at the station. This must be checked before operation in order to get accurate distance readings. Finally, there is the rheostat, which controls the rotation of the antenna. The power is turned on by the black button switch at the left. The red button turns it off. With the power on, the rheostat controls the starting, stopping, direction, and speed of rotation. With the pointer in down position, the antenna is motionless. Turning the control clockwise rotates the antenna in a clockwise direction, the speed of rotation being increased as the pointer is turned higher on the dial. For counterclockwise rotation, the rheostat pointer is turned to the other side of the dial. A quick shift to 0 will not stop the movement abruptly. It will only allow the antenna to coast. A quick stop is made by shooting the pointer high on the opposite section of the dial and then shifting it back to 0. These are all the oscilloscope controls: the antenna rheostat, the range dial, and the 4 signal controls: intensity, focus, vertical position, and sensitivity. When setting up the oscilloscope for locating targets, the operator adjusts the focus and intensity and positions the image. He then sets the sensitivity and rechecks the focus. As soon as this is done, he checks the 0 distance reading. This constant streaky pattern is called hash and is characteristic of the equipment. It does not enter into the actual business of locating targets. The operator starts the antenna. A target image first appears as a break in the baseline. Here's one now. As the antenna swings, the echo reaches a maximum and then diminishes. The bobbing effect of the echo signal indicates a moving target. This effect is not always registered so sharply. It definitely contrasts with the peak appearing alongside of the output signal, which may indicate a stationary target, possibly a steel tower or a tall building. Swinging the antenna still further, the operator picks up another signal. From this one, it can be seen how the number of planes can sometimes be estimated. Close examination will show that this signal is actually made up of 3 individual peaks, indicating 3 planes. Once more, the antenna swings, and this time the operator finds an area where there are several targets at various distances from the station. Each one of these peaks indicates a target. Through experience, the operator learns the sensitivity of the rheostat control so that he is able to keep the antenna right on the trail of a moving target. He also learns to approximate the direction and speed of a target. The operator tracks single targets for practice during his training period. In tactical employment, the antenna moves back and forth at a uniform speed, and the crew plots all targets within a definitely assigned sector without stopping the antenna. The azimuth reader sees that the antenna covers the assigned sector. When the end of the arc is reached, he calls out, "Reverse!" Here's how the crew operates as it searches an assigned area. The operator works the oscilloscope controls while watching the screen. The azimuth reader keeps his eyes glued to the azimuth scale. The range reader stands by to read the distance. And the plotter is ready to chart the points. The operator spots an echo signal and calls, "Ready." He lines up the left side of the echo signal with the center line, and when it reaches a maximum, he calls, "Read." The azimuth reader notes the number on the scale, 105. The range reader calls out the distance to the target, 23. The plotter swings the ruler to 105. And marks the point at 23. He then phones the point to the information center, where targets are marked on a large map called a radar board. The operating crew does not concentrate on a single portion of the sector. All targets are plotted, and the information relayed to the radar board plotters. The continuous and systematic search of a complete sector makes it possible to cover a wide area with a chain of overlapping sectors. Now let's see how a crew operates in a tactical situation.
72, fall, 4, 73, oval, 3, 9. Reverse. Ready. 3, 60. Three noble, 4, 1. Ready. 3, 50. $72, fall, 3, 5.
And 63 are enemy. Clear the board for action.
When it is determined that there is a flight of enemy planes, interceptor units are immediately sent out. Crew, in the meantime, continues to track and report all targets that appear in their sector.
Ready. 3, 68. 71, fall, 9, 8.
71, Paul, 9, 8.
The degree of skill the crew members of the SCR-270 obtain will be an important factor in fighting against the onslaught of Nazi and planes, and will help to blast them out of the sky.